The Mossbridge view of consciousness draws an intriguing analogy between conscious experiences and bosons in quantum mechanics, suggesting that consciousness might exhibit non-locality and indistinguishability, much like quantum particles. To understand this perspective deeply, and to evaluate its plausibility, we need to examine the core analogy between consciousness and bosons. Counterarguments from competing theories of consciousness. Empirical and philosophical challenges to the Mossbridge view. 1. The Mossbridge view, consciousness as non-local and indistinguishable. The proposal, inspired by quantum mechanics, suggests that indistinguishability, just as bosons, e.g., photons in a laser, are fundamentally indistinguishable, conscious experiences might not be uniquely separable. Two moments of joy, for instance, might not be different in an absolute sense, just as two photons in the same quantum state are identical. Non-locality. Bosons can exist in entangled states where their properties are correlated across space and time. Similarly, consciousness might not be strictly confined to a single brain or moment, but could instead be a distributed phenomenon. This view aligns with panpsychist and quantum consciousness theories, where consciousness is seen as a fundamental property of the universe rather than an emergent product of neural computation. 2. Counterexamples and competing theories. Several competing theories challenge the Mossbridge view. A. Classical computationalism, strong AI view. Claim: consciousness arises from complex information processing in the brain, and subjective experiences are unique to specific neural patterns. Counter to Mossbridge: if consciousness is strictly a computational phenomenon, then experiences are distinguishable because they correspond to different neural states. Two identical feelings of happiness would still be tied to different neurons firing at different times. Example: a digital simulation of a brain could, in principle, have conscious states, but each state would be tied to a specific computational step. B. Biological naturalism, Searle's view. Claim: consciousness is a biological feature of certain systems, like brains, and cannot be separated from their physical structure. Counter to Mossbridge: if consciousness is inherently biological, then it must be localized in space and time, within a brain. Non-locality would contradict known neurobiological mechanisms. Example: a brain in a vat would still have localized consciousness, whereas the Mossbridge view might allow for distributed consciousness beyond the brain. See functionalist theories. Claim: mental states are defined by their functional roles, not by intrinsic properties. Counter to Mossbridge: if two experiences play the same functional role, e.g., two instances of pain leading to avoidance behavior, they are functionally identical, but this doesn't require quantum-like indistinguishability. Example: a robot and a human could both feel pain in a functional sense, but their experiences would still be tied to their respective hardware. D. Dualist or interactionist views, Cartesian dualism. Claim: consciousness is a non-physical substance interacting with the brain. Counter to Mossbridge: even if consciousness is non-physical, dualists typically assume it is individualized, e.g., each mind is distinct. The Mossbridge view's indistinguishable aspect conflicts with this. 3. Empirical and philosophical challenges. The Mossbridge view faces several difficulties. Lack of empirical evidence. Quantum effects in the brain, e.g., in microtubules, as per Penrose-Hameroff, remain speculative. Decoherence in warm, wet brains makes quantum coherence unlikely. Hard problem of consciousness. Chalmers: even if consciousness were non-local, this doesn't explain why or how subjective experience arises. The analogy to bosons is descriptive, not explanatory. Personal identity issues. If conscious experiences are truly indistinguishable and non-local, how do we account for the continuity of individual selves? Normally, we assume our experiences are ours in a unique way. Conclusion: the Mossbridge view offers a fascinating but highly speculative analogy between consciousness and quantum bosons. While it challenges classical localization theories, it struggles against computationalist, biological, functionalist, and dualist frameworks that tie consciousness to specific structures or processes. Without direct empirical support, it remains a provocative hypothesis rather than an established theory.